Okay, we just had this lesson on pulse width modulation. And one of the questions was, what was the frequency of the oscillation between 0 and 5 volts? Now we know that it stayed constant, and what was varied was the amount of time that the function was on versus when it was at 5 volts versus 0 volts. So if it was, say, a digital or a analog value of 127, which is about half the maximum amount, it would be on half the time and it would be off half the time. Now he mentioned a period of 4 milliseconds, but I said it was 2 milliseconds. So how did I know that? So if you go to Arduino, let me just go to the main page here. So here's the main Arduino page. And then if you go to documentation, reference. So reference is, as the name implies, it's a reference for all the commands that are used in programming for the Arduino. So we have seen some of these already. We have seen the digital write command. We've seen the pin mode command. We just did the digital write command. And there are multiple, so you've got a group called functions, one group called variables, one called structure. Okay, so those are the main three areas. Now, the analog write command is right here under analog input output. And it discusses a little bit about what was just talked about in the tutorial. Analog writes an analog value, PWM wave, pulse width modulation, to a pin. Can be used to light in an LED at varying brightnesses or drive a motor at various speeds. After a call to analog write, the pin will generate a steady rectangular wave of a specified duty cycle until the next call to analog write. And here is kind of the details for the different types of Arduino boards. Now we are using a clone of the Uno board, and it says that pins 3, 5, 6, 9, 10, 11 have pulse width modulation pins. And here's the frequency. So it says 490 hertz. So I said 500 hertz or 2 milliseconds. Except for pins 5 and 6, where it is at 980 hertz. So here the period would be about 1 millisecond, whereas for 490 hertz, it's about 2 milliseconds. And you can see most of the time it's 490, some of them are 732. I don't know why they chose those numbers. But now, in general about reference, it usually talks a little bit about the command. It gives you the syntax. So this is analog write pin, comma value. It says that the value can go from 0 to 255. It's an integer type in terms of the variable. The pin is which Arduino pin, which is limited to those 6 pins. It doesn't return anything, meaning it doesn't give an answer. It just it does what it does to the pin, and then gives you a little bit of an example code. So let's see what this does. So we have an LED pin 9, an analog pin 3, a value of 0. It defines pin 9 as an output pin. Now, pin 3, it says analog pin is 3. It doesn't use a pin mode. It turns out for analogs, you don't need to specify. You don't need to use pin mode because analog pins are always, well, I shouldn't say that. I think there is an exception to it, but unless otherwise noted, it is a input. Whereas the digital pins can be both as likely to be input and output. Then finally, what it does is it reads a value from the analog channel, analog pin, and then it writes a value to the LED pin. And they take the value here and divide by 4 because the analog read command goes from 0 to 1023, as it says here, whereas the analog write goes from 0 to 255. So to go from full scale for analog read, you have to divide by 4 to get full scale for analog write. And there's some comment here about when you use pins 5 and 6, which have the higher duty cycle. Okay, so these are all kind of that way. Now, one thing also, if you go up here, there's a little link, PWM wave. So let's see what that says. Okay, this is just another description of how pulse width modulation works. Okay, that's all I wanted to say.